This is part 1 of the practitioner's guide to the GLM of the example I'm going to do. This example is from the source reading, where they have male and urban and male, female, urban and rural, and then they have how much it was for like the average for each section. And what you do is you try to create a regression model that predicts what the next policy is going to be, or what next claim is going to be based on male and urban or female or rural. And so you have 4 predictive variables, but you don't use all 4. You drop one of them because then it would just be, what was it said in the reading, monotonic? No, that's not it. But it's just it would just lose the error term, and it just wouldn't be like a linear regression model. There would be no error term if there was all 4. Anyway, so you can use 3 like this. So you use b1 times x1 plus b2 x2 plus b3 x3. Or you could realize, hey, you know what? I can just make an intercept like this. So put A, and then I could drop the female. So I only have one representation for the gender, and then one representation for the population of the city. And then I just put an error term, and both of these are just as accurate as long as you have this intercept term. So the B1 or B2 kind of acts as the intercept in both of them, and then it just adds on for the equation. But the main question is, how are we going to solve for what the B1, B2, B3 is? Because what these are going to be used for is, if you drop in another answer, it's like, hey, like what do you predict the next male urban to be? You know, and you could get an answer to that. You can even solve for the error term. And so here's what we're going to do. We are going to just write several equations out. So you have your first one. So this one, we're going to be the male urban. So that case, you can drop the B2 version. By the way, you first focus on the first equation, and then we could do the intercept one. So we're going to just do the B1, B2, B3. So this one, for the male urban, that one has B1, X1, and then you also add the B3, X3. B3, X3, and then you plus your error term, like that. And now I'm just going to pause the video, and I'm going to continue on with the rest of the equations written down. So you have here all 4 equations. So if you look at just this segment right here, the first plus the third, which is the urban, plus an error is 800. And then you do the same thing here, female plus urban, right there, that's the 400 plus the error term. And then here's the male plus error, and then here's the female plus error because rural isn't included, so the x3 is gone, and that's the 500 and 200. Now our goal is to solve for the sum of squares error, like find like the minimum error. So what we're going to do is we're going to solve each of these equations for E. So move everything to the other side, and then we're going to square it. And then we're going to find the minimum, which means we need to do some deriving. So now, because we need to focus on all equations, we combine it right here. So it's all squared. So you have like this all moved to the side, and then you have it all added with all 4 equations. And then you do a derivative based off of the 3 predictor variables. So x1, x2, x3. Because the error term would be considered a constant there, that would become 0, and then so that's where we do use the power rule. You just move the 2 into the front, you have the first section, and then you have everything based off of B1 is kept. And then this one, derivative, the B2, only everything that has a B2 would be kept in this one, and so forth. And then you could just solve for the equations, and then with the system of equations, so it's pretty nasty, honestly. And I think it would be pretty ferocious if they did on the exam. But you just have B1, B2, and B3. One note of a thing I did wrong in these equations is when you have these 3 equations set up, you either have x1 equal 1 or 0. So it went away because it was 0, but x1 really should be a 1 here, so you just have B1 or B2 or B3.